Hi, I'm Bob. Welcome back to the Solutions to Microeconomics Theory and Applications with Calculus, the 5th edition. I think I made a mistake in exercise 2.4 in the last video. I want to correct it in today's video. Let's calculate the compensating variation, the equivalent variation, and the change in consumer surplus again for that exercise. Since the compensating variation is the money that should be given to the consumer to restore her original utility at the indifference curve I1, we should compare the expenditures at bundle A with bundle C. The expenditure functions are the functions of prices and utility. Both A and C are of the same utility, U bar. At bundle A, the consumer faces the old prices P1 and P2, while at bundle C, the consumer faces the new prices P1 star and P2. The difference between the two expenditures is the compensating variation. Similarly, when we calculate the equivalent variation, we compare the expenditures at bundle B and bundle D. The expenditures are functions of prices and utility. Both B and D are of the same utility, U star bar. The consumer at bundle B faces P1 star and P2. The consumer with bundle D faces P1 and P2. The equivalent variation is the difference between the two expenditures. We have the utility function. Using the Lagrangian method, we can obtain the compensated demand function in terms of prices and utility level. To calculate the compensating variation, we need the expenditure at bundle A with P1, P2, and U bar, and the expenditure at bundle C with P1 star, P2, and U bar. Then we can obtain the difference between them as the measure of the compensating variation, which is 4. For the equivalent variation, we calculate the difference in the expenditures between bundle B and bundle D. They are of the utility U star bar. Substituting the P1 star, P2, and U star bar into the expenditure function gives the expenditure at bundle B. Plugging P1, P2, and U star bar in the expenditure function yields the expenditure at bundle D. The difference between them is the equivalent variation, which is also 4. The change in consumer surplus must be between the compensating and equivalent variations, so it is also 4. This method not only applies to the quasi-linear utility function, like in this exercise, but it can also solve for the compensating variation, equivalent variation, and the change in consumer surplus for the Cobb-Douglas utility function. Let's look at exercise 2.5. The consumer has a Cobb-Douglas utility function. His income is y equals 100. Initially, he faces prices of P1 equals 1 and P2 equals 2. If P1 increases to 2, what are his compensating variation, the change in consumer surplus, and equivalent variation? We use the same method as the last exercise. In the first step, we use the Lagrangian method to find the compensated demand functions for Q1 and Q2. The first two first-order conditions give the price ratio and we can write Q2 as P1 over P2 times Q1. Combining it with the third first-order condition, or the utility constraint, gives the compensated demand function. The compensated demand functions hold the utility constant. In the second step, we substitute the quantities into the expenditure expression and get the expenditure functions for bundle C and bundle A. Plugging in the price values gives the compensating variation in terms of utility level U1 bar. Similarly, we can calculate the expenditures for bundle B and bundle D and then write the equivalent variation in terms of U2 bar. The third step is to compute the utility levels. We can directly write down the uncompensated demand functions for a Cobb-Douglas utility function. For P1, P2, and Y, we can compute utility level U1 bar, which corresponds to the indifference curve I1. For P1 star, P2, and Y, we can compute the utility level U2 bar, which corresponds to the indifference curve I2. In the fourth step, using the utility levels, we have the compensating variation and the equivalent variation. They are 41.4 and 29.3, respectively. In the fifth step, we integrate between 1 and 2 to the left of the uncompensated demand curve to find the change in the consumer surplus. It is 34.7. We can verify that the size of the compensating variation is larger than the change in consumer surplus, which is larger than the size of the equivalent variation. Thank you for doing the exercises with me today. See you tomorrow for the rest of the exercises for compensated consumer welfare. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.